Table tennis stroke training is fundamental for player development. During practice, players often struggle with perceiving the correct motion trajectories spatially, either from an expert's demonstration or their own attempts. Meanwhile, existing table tennis approaches lack intuitive visualization for teaching players stroke movements effectively. To address these challenges, we have developed an augmented reality system called avaTTAR for table tennis stroke training. avaTTAR is designed to offer a unique combination of on-body and detached visual cues. The on-body visuals overlay virtual cues directly onto the user's physical body, enabling first-person view guidance. The detached visuals separate cues from the user, facilitating third-person observation of movements. These cues are all aimed at improving the learning experience during stroke training. To gain valuable insights, we initiated our methodology with formative interviews encompassing a diverse group of 11 table tennis players. We focused on 3 essential topics, including table tennis training experience, challenges and pain points, coaching and mentorship. After our discussion with the interviewees, we then derived 4 requirements for our system, which are motion reconstruction, stroke comparison, demonstration and feedback visualization, and interface for visualization interaction. Additionally, we break the requirements into 9 components for implementation. We developed authoring software to record expert stroke movement data, along with a learning system based on the design requirements mentioned before. There are 2 modes for the authoring software, which are record mode and edit mode. With the record mode, the author presses the start button, performs the stroke, and then presses the stop button. The edit mode allows authors to trim the records with the start frame and end frame buttons. The authors can also specify keyframes for the recorded movement with the keyframe button. After editing the data, the author could use the save button to save the movement record. The learning system comprises 4 modules, each playing a distinctive role in its overall functionality. Motion capture. This module is responsible for capturing and tracking the user's movements in real time using a combination of hardware, including a webcam and IMU. And algorithms for data processing. Stroke analysis. In this module, the system analyzes the user's movements and compares them to expert data, providing insights into the accuracy and alignment of the user's actions. Cues visualization. This module involves the presentation of visual cues to the user, including on-body cues and detached cues. On-body cues provide correct movement trajectory guidances for the body and paddle. Detached cues provide an expert avatar that shows correct movements and a user avatar that shows the user's movement and highlights incorrect skeletons in pink. These cues help guide the user in real time during training. AR interface. With this module, users have the freedom to pick the stroke they want to train. Moreover, during the training process, they can easily choose their visualization preferences using the interface. We now elaborate on an example of using our system. The user selects a specific table tennis stroke during practice, then the system will display the expert avatar executing the selected stroke. The user could adjust the stroke play speed of the expert avatar to gain a better look. Additionally, the user could walk around the avatar to observe the stroke movement and pause anytime they want. After observation, the user could start practicing with the expert avatar. The user could choose to display an user avatar. The user avatar accurately reproduces the user's real-time posture and highlights the error joints. At the same time, the system closely monitors the user's movements, offering on-body guidance for optimizing the corresponding errors. The player could pick to visualize the guidance for the body and the paddle based on their preference. We also did a 2-session user study to verify the efficacy of the system. For more details, please refer to the paper.